but in the interest of time, I think we better start the session, if you agree, Dr. Endalkachew.
Yeah, I'm ready.
Yeah. Okay. So I'm Mafalaka Zauga. I'm director of the Africa Center of Excellence for Water Management. And dear participants, invited participants, thank you very much for joining us on this important monthly webinar series of our center. It's my pleasure to introduce our speaker today and also our moderator. So our speaker is Dr. Endalkachew Sahle, who is a senior scientist at U.S. Environment Protection Agency, Office of Research and Development, Center for Environmental Solutions and Emergency Response. So he has received his MSc and PhD in chemical engineering from Oregon State University in USA. His research focused on seeking engineering solutions to emerging contaminants of concern, including developing sustainable water treatment technologies such as advanced oxidation technologies and desalination processes, as well as strategies to reduce the risk of emerging contaminants of concern. Innovative technologies for water treatment of contaminants and sustainable management of solid waste, including electronic waste and plastics. So the Dr. Sahle Demessie holds 5 US patents and has published over 130 peer-reviewed research papers. He has received several awards, including the 2003 EPA STD Individual Achievement Awards, the 2004 IGERT Award, multiple EPS Science and Technology Achievement Awards, the 2019 US EPA Honor Awards, 6 US EPA Path Forward Innovative Project Award, and the 2013 US EPA Silver Medal Award for Superior Performance. We really appreciate Dr. Endalkachew for his interest to give us a lecture today. Our moderator today is Professor Tekettel Yohannes, who is a professor of physical chemistry at Addis Ababa University. His research focuses on photovoltaic and photoelectrochemistry of organic conducting polymers, materials, and solar cells. Professor Tekettel has published over 80 peer-reviewed research papers. Furthermore, he served as chair of the Material Science Program at College of Natural Science of Addis Ababa University, Associate Dean for Graduate Program at the College of Natural Science of Addis Ababa University, Director for Research at Addis Ababa University, Vice President for Academic Affairs at Addis Ababa Science and Technology University, and currently he is Executive Director of the Ethiopian Academy of Sciences. So I again thank our moderator for his interest to facilitate this session. So the floor is now yours, Dr. Endalkachew, which will be moderated by Professor Tekettel. Thank you very much.
Okay, let me, thank you, Dr. Famaka, for that introduction. I'm also excited to be given the chance to participate in this lecture series, as this is a very important issue, the water issue, as you explained, that I have been involved in various aspects of water technologies, particularly on the technology side. So the discussion here today involves policy, technology, and the role of energy, particularly renewable energies, in addressing water issues. So in Sub-Saharan Africa. So let me try to. I want to share my slides. I don't know if you can see. Can
yeah, we can see, but if you can use slide show.
okay, you can.
Yeah, slide show, yes.
Can you?
It's
okay.
Yeah, it's fine now.
Okay, can I? Okay. Okay, so there is a standard disclaimer from EPA, that's the US EPA, that this does not reflect the policies of the agency, and the presentation has been cleared by the US EPA. So the outline of my talk will be as follows. I'll have a general introduction over the issue of water and the implication of water shortage and the issues related to it, particularly with climate change, and the impact of it to various aspects of social, economic aspects, the urban-rural divide in water supply and water resources for Sub-Saharan Africa. And then I'll talk a bit more on the general issue of what is the role of solar energy in addressing this challenge, and give example of some of the solar-based technologies, either direct or indirect technologies that could advance the provision of water treatment, water supply, and give some examples from our own research. So I'll talk more in the proven technologies and tools from a wide range, from proven technologies to technologies that are innovative at early stage of development that may require some, they are far from being practiced, but also have some potential. So, and then I'll conclude my talk with some general outlook. So, sorry. So we have a beautiful blue planet, which is primarily consists of water, where 75% of the Earth's crust, the surface is covered with water. However, this water is in the oceans, highly saline water. So the portion of clean fresh water, drinkable water, is only 2.5% of the global water, and out of that, the surface water, which is available for our sustainable existence, is only 1.3%. So we really have to be very efficient and effective in using this water. Should not pollute it or use it very effectively. So, and this, because of this, there is a global water scarcity. That water scarcity is defined as a lack of freshwater resources to meet the standard demand of water. And currently, 1/3 of the global population lives in countries where there is water scarcity, or the water quality is compromised by various for various reasons. So and there are many factors, growing factors that are impacting both the water quality and the quantity of water that's available for our existence and sustained presence. So what is water scarcity? That depending on where we live and the conditions, the standard of living of those countries, or the technology and the capability of this country. So there are a range of water causes for causing water scarcity that most of North African and Middle Eastern and Central Asian countries, including Mexico and Southwest United States, suffer from physical water scarcity, where there is not enough water to meet the demands of what is of the public, the people. And also including farming and other applications. So those really have a shortage of water. There's not enough water in those countries, but much of Sub-Saharan African countries have plenty of water, but the lack of water and infrastructures, inadequate human capacity is causing. So there is economic water scarcity and which is easier to, relatively easier to address than the physical water scarcity. So, but the projection is that in the coming, by mid of 2020s, that two-thirds of the water people live in countries where there is under some form of water scarcity, and that is partly because of there is increasing land and arid lands, and then we have seen some of the major cities like Sydney, Australia, or Cape Town, South Africa, in the past few years have been severely, there is a severe water shortage, which we haven't seen for almost a century, that kind of water shortage in large metropolitan areas. And these are all indications that this is a major problem. And that is why in 2016, there was the Global Economic Forum has asked about 750 experts to assess different threats. What are the global risks? And there are 25 separate global risks listed there, and they're asking to their projection of what in the next 10 years, so what are the major global risks. And water scarcity is became one of the top. It's a more serious risk than climate change, the food crisis, migration and displacement of people. Now, of course, this was before COVID, and now we have seen in the last year there are some other unforeseen challenges. But water issues is not going to go away. COVID may go away in the coming year or so, but not water scarcity. And the link of water scarcity with other issues, economic issues, social issues, and technical and environmental risks is it's connected to a lot of other problems. So this is, this continues to be a challenge. And in Africa, what we have seen actually is that there is a United Nations Development Goal by 2030. There is a goal to achieve universal and equitable water supply for either safe water, for drinkable water, and also sanitation to the global population. So there is a lot of progress towards this goal, but Sub-Saharan Africa still is behind in achieving some of these goals. Part of the challenge is that the water scarcity issues also affects the women and children because of they are more involved in fetching water and collecting waters, which could take a couple of hours a day. So it has a lot of social impacts. And the other is when we look at the projection of the next decades, there is one from World Resource Institute projection is that what increasing of climate change could impact, could worsen, especially in some parts of the globe, could worsen the scarcity of water. So assuming that business as usual, most Sub-Saharan African countries probably will remain near normal or the baseline, but other places, Australia and North America and most part of Asia will have more impact because of climate change. So, and as a result of this, World Bank actually 2 years ago came up with a projection that as a result of the increasing water scarcity exacerbated by climate crisis, could cost some of the regions up to 6% of their GDP. So the combined effect of population growth, urbanization, expanding demands because of increasing in GDP could increase the water usage. But actually in one study, that every doubling of GDP quadrupled the water usage, and the water supply in many African countries is seasonal and unevenly distributed. So efficient use of water is critical. And so when we talk about water issues, that I want to kind of put it into different categories. That the water shortage may be due to lack of inadequacy of water resources, but in most Sub-Saharan Africa, it's lack of capacity. But so there's a water availability issue because too little water in some areas, and the seasonal variability. The other is accessibility of water is an issue, and so the third area is water management. So because allocation and conservation and catchment of and reuse of water that is not is really lacking. So water management issue is a serious problem. It's still a big problem. And now increasing of industrialization in many parts of African countries is affecting also water quality. But this is other developed countries have gone through it. China has gone through it because of rapid industrialization causes a lot of contamination from municipal, agricultural, industrial waste. And these pictures here are taken actually from parts of Ethiopia for discharge from industry or agricultural discharge could affect water quality. And the other issue is water inequities in water is between rural and urban areas. So what's connected to this is water is still a scarce resource. However, that water is connected to food security and agricultural resources and agricultural practices. So a sustainable use of water is closely linked to food security. So a resilient water infrastructure systems are needed to provide fundamental ecosystem services. So this is that from providing enough sufficient amount of water to avoiding excessive pollution in some of the lakes and rivers. So we start seeing this in many parts of Sub-Saharan African countries. So and on top of this, there are some local and global factors that, like what I mentioned, population growth and increased standard of living and urbanization that is impacting the quality of water. If we, I want to give you some of the data I found that maybe not current, but very unique to the challenge in Sub-Saharan African countries is that when you look at the water distribution in Sub-Saharan Africa, in African countries, is that the Central and Eastern and even Western African countries have plenty of water. There are many large lakes and rivers, and but Northern Africa, as you see, is only 1% have only 1% of the total water resources for Africa. But when we see the water utilization by African countries, by regions, that the Northern African countries have a better water utilization, a much higher water utilization, although of course they have limited resources, but compared to the other regions, that East Africa has only less than 10% of water used, and the Central, of course, they have plenty of Central Africa has plenty of water, but and most of this water is used for agriculture. That is not just unique to Africa, but to Asia. That's global. That most of it's used for agricultural purposes, but a very low amount is less than 10%. Is used for industrial use. So, and if you see, I have here listed about 16 countries of water withdrawal from how much water they are using from what's available for them. And you can see Northern African countries that like Algeria or Morocco are using quite a big fraction of their what are available. Countries like Egypt are using about more than what's available. They had more than 100% because they also do desalination. Whereas other countries are not utilizing the water, exploiting the available water resources. Kenya or Ethiopia are using less than 6%, whereas Congo don't even use 1%. So it's just not the availability. There is plenty of water available, both groundwater and surface waters, but the challenge is more of the making these resources available to the population and making it affordable and making it a sustainable supply of water to both rural and industrial, rural and urban population. So if you look at this divide between the rural and urban areas, and I have here it's not a recent 2008 UNICEF and WHO studies that in most of the African countries there's a big divide between the availability of water or potable drinkable water to between rural and urban urban population. So in some of the North African countries, surprisingly, they have very good, very close amount that the difference between the urban and the rural is very low. So there's a sufficient amount of water supply for both in rural and urban areas. But in other areas, there is a big divide. So that means that this is more a challenge of the available technology. So there's abundant water resources in the middle of the continent, in the eastern and western part of the continents, but these resources needs to be available to the people at an affordable way, in a sustainable way. So that means that and this is where I think that solar technologies, small scale and medium scale solar technologies can be used for helps to address these issues. Of course, there needs to be more wells, needs to be available. So rainwater collection schemes needs to be developed, but so it's the issue of technology needs to be addressed and this is where I feel that solar technology could fill this gap. So some of the potential measures to improve the existing water resources is water conservation, but also building and improving the water infrastructures, but improving catchment and distribution systems. And so to increase water supply beyond the hydrological cycles, so we need to have low-cost energy supply, and to increase to access groundwater and to recycle water, and that's so. And then desalination in some areas of brackish or saline water is another choice. So I would. And here it's I will mention about the relationship between energy and water is that you need to have energy to treat water and to access water, but also for a lot of power generations, especially thermal power generation, you need to have water also. So the two are closely linked, and they are also linked with food security. So energy, water, and food are closely linked. Factors that you need one to access the other resource. Moving away from the thermal generation or fossil fuel to a renewable generation, energy generation could help us to attain a sustainable water management system. And when you see the capacity of generation of potential generation of energy, that most of African countries have not even tapped a fraction of what's their potential. For example, just take the example of Ethiopia, is that the capacity that was estimated in 2014 is about 78 gigawatts, and this is right now, the current generation is less than 10% of that. But on the other hand, what you see is that this estimate does not include solar, and even without that, what we can see is there is there is a rapid increase in access to electricity by most Sub-Saharan African countries, and this was a recent study from World Bank and the International Energy Agency, that from between 2010 to 2018, there is a 42% increase. So I feel like we are getting to the inflection point that approximately with this at this rate that the increase in access to electricity could be reached in the next decade or so. So there's a lot to be optimistic about this. So I want to talk a little bit more about solar and what could solar bring to this. And by the way, solar is not new. I want to quote Thomas Edison, the famous inventor, American inventor, and which he said about 90 years ago, that he said we should be using nature's inexhaustible resources, sources of energy, sun, wind, and tide. And I would put my money on the sun and the solar energy. What a source of power. And I hope we don't have to wait until oil and coal ran out before we tackle that problem. So, I mean, he was saying this to Henry Ford, which is the Ford CEO of the Ford company, and also to Firestone. So what I see here is that there is a lot of potential that people have noticed it, thought about it a long time ago. And Africa is rich with this. So much of Sub-Saharan Africa received solar radiation that is at the order of 6 to 8 kilowatt hour per meter square per day, which is much higher than most of the globe. And this is all year round. So there's a huge potential for solar to generate electricity both off-grid and for grid providers. And one estimate by IEA is that the countries South Africa, Ghana, Kenya, and Rwanda could access electricity, could reach full access to electricity in the next 2 decades. So when we talk about solar, I want to divide into 3 parts. That the main part is where solar energy can be used by photovoltaic cells to generate electricity, and that electricity is available for a wide range of applications for households, a range of applications, including for water technologies. The other is the solar energy can be used as a form of heat to do some kind of distillation or thermal distillation technologies. And the third one, which is not, you don't see a lot except in some Northern African countries, is that solar concentrators, which is used to drive, intense heat, generate intense heat and drive a turbine, which is similar to heat power plants. So the one that is really growing fast is photovoltaic cells. The cost of them has really gone down in the past decades. And when you see the projection of what's current and what is will be coming, that renewables have a leading role in meeting the future demand of Africa. So to date, there is about 5 gigawatts of solar power is installed in whole Africa, which is less than 1% of the global total. But Africa's vast renewables could increase this use, tap this energy source, and the projection is there is an increase about 15 gigawatt per year, and which is a huge amount, and could overtake hydropower and other forms of power. And as you see here on the bar chart, there is the orange boxes showing that in the next 40 years, 20 years, solar will be contributing to a big portion of the total energy. And solar, off-grid solar power can be used in Sub-Saharan Africa for a place where energy is needed. So the neat thing about it is that you can place it incrementally from a small scale to depending on the demand. It can be modular, so you have a mini grid in remote farmers or villages, or increase its use as the demand increases. So and it can be used for agricultural application, for irrigation, for pumping, and for other farm applications. So that is why I think that solar energy has a potential to transform rural Africa and hopefully narrow this gap between the access to clean water between the urban and the rural divide. I want to talk a little bit more about solar water treatments, purification, desalination, distillation, and disinfection. Now, in a small scale, there are proven techniques for solar disinfection technologies. Solar energy can be used to disinfect drinkable waters, which is a direct use of solar, no electricity or anything. There are other solar distillation technologies, thermal distillation, or the solar energy can be used to generate electricity and run membrane processes. So a wide range of options are there depending on the cost and availability of technology. If we look at the solar disinfection technologies in small scale, this is it's an effective way. The WHO is promoting this, that it's suitable for developing countries that lack access to safe drinking water. So it's what's called SORIS have shown some been promising, but it's still one is a very low, small scale, and it's only for treating pathogens. But it's a solar technology, but it can be scaled, and here's then a scaled system to up to 200 liters in 5 hours. So you need to, I think, in an intense sunlight, you need to expose the water for about three hours to completely disinfect it. The other is desalination. I mean, there's a lot of brackish water, and many countries have also have access to seawater. So, and that is there's a lot of resources that can be treated and be used for tap drinking, for drinking water. So a range of technologies are there, and one is the simplest one is direct solar desalination. So this is direct solar desalination is a low capacity. So where the solar energy is used to heat the water, and then it's condensed. So this occurs like in a greenhouse, but the amount of capital investment in this is limited, very low. But you can generate up to 5 liters per meter square, which is about 200 meter cubes per day. So it does require a large area if you want to scale it up. But the technology is available for areas where there is water, brackish water, that can be converted into drinking, drinkable potable water. So there are some cost estimates for this, and cost estimates is what I've seen is about 1 cent per liter of production. So it's compared to if other technologies are other water sources are not there. This could be could provide water for small village or small communities. So and there are many ways of improving it, but you have to look at the simplicity and the economic feasibility of a more complicated system. So the other in some areas, this is also connected to greenhouses. So we can integrate the design of a greenhouse combined with solar stills. So this way you can use for not only generating the from brackish water, you can do some greenhouse farming, basically. So that is both providing drinkable water and small scale farming. So another is this is also used in Southwest US, also in some areas where flash distillation of using thermal, and this is currently the dominant thermal desalination technology, that about 20% of worldwide desalination technologies use thermal processes. But it requires some capital investment, but it is feasible for a lot of, in many parts of African countries where there is plenty of brackish groundwater. But when the major desalination technology is reverse osmosis, and it has a lot of potential and used widely in the Middle East, in Saudi or in the Gulf countries. But it's there is a lot of capital investment, especially in membrane technologies. But the technology has improved over the past 40 years. The cost of water production has gone down, and the energy used has gone down. But it still has a lot of environmental impact, and there is the issue of public acceptance. So we worked a lot on this. How on the issue of addressing some of the energy demands for reverse osmosis technologies, but there is a thermodynamic limit to how much energy is needed for a reverse osmosis, and that is about 2.8 watt per hour per gallon of water. And when you see that from the 1970s to today, the energy demand for this technology has really has declined. So there's a lot of improvement in the type of membrane and the operation both in forward and reverse osmosis, but we still the cost is still far from for a lot of countries, but it is it could supplement some especially urban areas in some African countries. Djibouti, for example, uses a lot of its part of its water from desalination. So the conventional desalination technologies are large-scale technologies. They are intense energy demand, but the problem of brine disposal is there. So we are looking for a better improvement from an alternative to this desalination technology. One is that to use sunlight to generate electricity and use that to run your system. Again, the cost of the technology for membrane is there, but and the cost of disposal of the brine is an issue. However, integrating this with solar energy could reduce the overall cost of the system. So, the abundant resources of sunlight and avoiding fossil fuels could have a lesser environmental impact or footprint. However, the technology in a large scale is and increasing the technology to a large scale is still a challenge. And of course, you can't use this for agricultural application. So the other way that is an experimental techniques that we are still developing and collaborating with many people, including Dr. Foleka's group, is biodesalination. This is a very innovative technology at a very early stage, but now there is a lot of interest on this because of this could address some of the this has some potential. If it works. So the idea is to use algae, halophytic algae that which can live in acid saline environments. So to use these algae that actively grow in saline environment that absorbs the salt, and then the algae. Can reduce the water salinity, and growing algae at a large scale is already a proven technology that's used for for biomass biofuel generation. So we have done some work on this, and others now in the United Arab Emirates, in Chile, and in Ireland. This research has continued, including what I said in Ethiopia and Egypt. There is a further continuing of this research. So what we envision is that the biodesalination can be integrated with energy harvesting, harvesting the algae for energy use, and also it can be used for CO2 sequestration, because you need CO2 for growing the algae. So this is at the early stage. So I'm not sure if this will be feasible or not, but this is, again, it's using solar energy. It's an alternative way of providing clean, safe and water for especially agricultural application. So lastly, I want to talk a little bit more about decontamination. So this is an issue in many. It has become an issue as the countries become more industrialized. There are solar-based treatment technologies. I mentioned SORIS, but one is solar decontamination photocatalytic treatment. Again, this is our group has done a lot on this photocatalytic treatment of contaminated water. But again, the chemistry is very good and it works for a lot of organic contaminants. But however, there is an issue of scaling up, and there is an issue of the cost of this technology. When we looked at it, that in a lot of this is on methyl tertiary butyl ether. This is a water contaminant that is used for making diesel, gasoline here oxidized. So it's added to gasoline. When it's discharged and contaminates groundwater, you can treat it using solar, actually, with photocatalysts. However, in lab scale and small scale, it works fine. But in an actual groundwater where it has a lot of other ions, that the technology is not as effective. So there are a lot of technologies that are require solar that works in solar energy, especially in small scale, but scaling it up and making it available and requires further development. So I just want to mention one or two, especially what is the future here in countries like Ethiopia is that there's a great progress has been made in the past 2 decades, and solar capacity of solar, this orange and red shows where the potential for solar is high. So from what I've my think is that the potential for increasing solar energy, especially for as an off-grid solution, is high in most of Sub-Saharan African countries. So we need to diversify the current energy generation and to make it more climate resilient, and that achieve to a better future. So I want to conclude my talk. I want to conclude my talk that water security is critical for a sustainable growth and to develop a resilient water supply systems, and renewables, especially bio, hydro, and solar, have a high capacity to address this, and the high capacity still have is untapped resources that could address this issue. And off-grid energy generation allows the innovation of water supply and water treatment and recovery. And so further investment in science, technology, and could have major advances in providing affordable water for Africa. So as we see here is that energy, food, water is what we call the nexus. But all these issues are also connected to social issues, as we see here, that the issue of water, whether it's health, education, women's rights issues, and also environmental issues. Contaminated water has an impact on the ecosystem. And also what we see now in many parts of the world, including the Nile Basin, is that water issues is a geopolitical issue also. So that is why I think when I quote previous President John F. Kennedy, who said anyone who can solve the problem of water will be worth of 2 Nobel Prizes, one for peace and the one for science. So this is, although 60 years later, the problem of water is still there, but advances in science and technology have given up ample confidence that Africa will overcome, Sub-Saharan Africa will overcome the challenge within the next decade. So there should be more effort is needed for a better water future, because without water, as chemical and ACS says, without water, there is no future. So I thank you for your attention, and I thank you. I would be glad to answer some questions.
Okay, thank you very much, Dr. Endalkachew. Let me briefly say some of the important points that he mentioned. I will not summarize the whole thing, but I will raise only the main points. He started in discussing on the distribution, scarcity, challenge, and he looked into also the resources and resource utilization globally, and he also described the African context, and he also mentioned about the solar power, its importance, its distribution, and at the end he looked into the various treatments, ways of wastewater using solar desalination, and also the biodesalination. And at the end, he also mentioned about how to detoxify using inorganic semiconductor like titanium dioxide, using a process known as photocatalysis. And he also mentioned briefly the profile of energy, not only in Africa case, but also the Ethiopian profile. This is some of the point that he mentioned. And so now it's time for question, reflections, and if you have any comments. So what you could do is you can raise your hand virtually. That's one possibility. And I see also at least one question in the chat box. So we can start with that. I don't know if Dr. Endalkachew accesses that, but one of the questions that was raised in the chat box says, how do we see the cost effectiveness of harnessing solar versus conventional water systems? So in particular, using solar energy for treatment, as was mentioned, could be a solution, but what about the cost vis-a-vis the other treatment technique? This is one of the questions that I looked into the chat box. So let's start with that, and then we will entertain other questions if there are any.
So, I mean, that's an important question, and that is why I think we have to compare costs of the various options we have. A study I've seen here from University of Iowa is that getting the power from from the grid, the electric grid, cost an average of $15,000 per kilometer of just transmission lines. So think about that. If it, depending where the location of a village is, that how far it is from the grid, and so to access to that electrical supply, the cost has to be compared. So it's for places where that are far from the electric grid system, the cost of an off-grid solar power generation is a much better, much attractive option. But and the other thing is, of course, that the grid is also is not resilient. It's not. It still has in many African countries the power supply, the electric supply has a lot of challenge. So it has to be it's situational. That's for people who are living in close to the electric grid system, that they can easily access it. But electric, it's not generation, but the transmission of electricity is costly. So for solar is a big, a better alternative for location for places where it's off the grid. So yeah, that is. And the cost. The other thing is that the cost of solar panels. Compared to what they were 20 years ago, it's much reduced to that. 200 or 100 times cheaper today than they were 20 years ago. So I think that is why this is an attractive solution.
Okay, thank you. Is there anyone who would like to raise any question, comment, suggestion from the participants?
I think that there is a question about the disposal of.
There are two questions in the chat box. I wanted to give the chance to the audience. Otherwise, there are two questions in the chat box that I can.
Can I come in here?
Yes, go ahead.
Sure.
Thank you very much, Dr. Takatel. Let me first thank Dr. Endalkachew for his very clear and informative presentation. My name is Abebe. I'm the Climate Change Officer at IGAD Climate Prediction and Application Center based in Nairobi. So what I would like to ask Dr. Endalkachew is, you have shown us the economic scarcity of water. If you compare the East African case with the North African case, they are much ahead than the region. And it's because we are not utilizing our water. So I think the capturing water in terms of dams, like the Gerd dams and others, will be really very important for the region. Even if we compare the developed countries capturing capacity using dams to compare to Africa is much higher. That's where the biggest difference comes in. So I believe that we need to have more storage capacity by building more dams in the region. That's one. I fully agree that the need to have capacity for water management, energy management is very important. Capacity building, especially from people like you. You can share that experience for the developing countries, including Ethiopia. The last question which I would like to raise is Ethiopia, when we're using dams, hydro, there is also recently the idea of even having nuclear energy. Renewables also are coming. So my question is there any work done on the economics of energy? Which ones are best? which way should we go? Is it for nuclear energy, for hydro energy? Is it for solar? Is it even for geothermal? Is there a study done on the economics of energy at the national level? I would be happy to get information on it. Over to you. Yeah, thank you very much.
Okay.
Dr. Endalkachew, the floor is yours.
Okay. Yeah, thank you for that question. It's really you raised two important issues. One is the issue of catchments, and this is very important because Ethiopia receives, or Kenya, most of the African countries receive sufficient amount of water to sustain what is the minimum requirement for water supply for the population. However, that one is that the rainfall is seasonal, and it's not and it comes within a certain time of the year. It's erratic. So water harvesting, water catchment is critical. And it can be done. It should be done at a small scale, and it should be done at a large scale, like the GERD type, larger hydroelectric dams. But it's you see the experience of Australia, especially over the past 10, 15 years, that they experienced a severe water shortage, and so they had to really manage their water. By increasing water catchment, increasing rainwater, and using water for separating the water that's used for clean water, for drinking water, to that for other applications. So I agree, I fully agree that it needs to be done at different scales, so that water collection and making it available to the public at both in small scale dams and large scale dams. And here in the U.S., for example, without the Hoover Dam, which was built about 90 years ago, is that much of the western United States, Arizona and South Nevada, I mean, there will be a desert. There will be desert. Nobody would have been able to live there. And now that the reason they sustain this large population is because of one huge dam that they able to on the Colorado River. So that is. So dams could have a critical advantage, but they are costly. They are very expensive projects. I think that to reach the rural population of Africa, to address some of these basic needs, that we need to look at small-scale solutions also. And the other questions you have is that there are different options of energy options, varying from hydroelectric system to nuclear. I think we have to look at the capacity, the initial investment, and the time. Look at the GERD dam. The time it takes and the cost of it's huge, and it's located at it's located far from the major urban areas, so the transmission there's a cost is also there. So. I think solar fits. I mean, one is that from what even in Ethiopia there is an understanding, and most African countries, and in Kenya and Tanzania also, I see that there is an understanding that we need to have a mix of different options, energy sources, to have a climate resilient energy generation. So and different scales. So I think there is. For countries like the Congo or Ethiopia, there's the use of hydroelectric generation is high. However, but they need to have a mix of that. There's solar, wind, and I'm not sure about nuclear because it has also very capital intensive. But just to give a short answer is that we need to have a mix of all this. And the initial capital investment and the cost of, including the transmission cost, should be taken into consideration.
Okay, thank you. Let's go to the chat box. I see 4 questions there. 2 of them are on SODIS, mainly related to microplastic pollution. And I see also the third question on disposition of batteries, which are used in solar photovoltaic devices. And the fourth one is a question that was raised by Fallaka, which says, how come Egypt use 134% of the available water, and how this is possible? So can you treat those 4 questions? I hope you see them in the chat box too.
So yeah, let me, I'm not sure about, I captured the first question, but I just, the issue of disposal of batteries is important. And actually, that is one, even here in the US, that is one area which I'm working on, that all electronic waste, not all just batteries. Batteries it's very important, but electronic waste disposal, including even solar panels. You know, solar panels have about 25 years of lifetime. So what to do with them after that? And so there's one of the projects that we do within the US EPA that I'm leading also is the issue of disposal of both solar panels, electronic waste, and batteries. So a safe and disposal of this is important, and that is that is a fair issue. That needs to be looked at. The full life cycle of the full life cycle impact of this implementing these technologies. So I think Dr. Fallaka's question about can a country be withdrawing more than it's what's available is. I think by what here that data from what I see, my understanding is that some countries, what the water resources available for both groundwater and surface water, they also get some water from the ocean, so desalination. So North African countries are using quite a bit of almost whatever water available, almost full, close to full utilization of available water. So I got that from another study. So, but that is what is what my understanding is that. But the take home here is that much of Sub-Saharan Africans are underutilizing or exploiting the water resources they have. So what was the other question? Did I miss?
The 2 of the questions are related on SODIS, and both related to microplastic pollution.
Yeah, so that's a good question. I mean, the issue of plastic waste and the issue of maybe something's leaching from the plastic is important. But I think I haven't looked into what's leaching here, especially for peat. It is the type of plastics used for drinking for bottled water. And by the way, bottled water use of bottled water has really increased in Africa over the past 30 years. So it's especially in urban areas. Now when you put it in that intense heat of solar light, there is a potential some of not maybe the plastic, but some additives could be leached. So I think that needs to be looked at. But I put that because WHO promotes this, and but it is that needs to be looked at. I can't give you a full answer for that. But I think that's a fair question. Now, the other issue of plastic waste, just like other industrial waste, which is solid waste coming from electronic or used electronics is a serious problem, I think.
The other question is it possible to use solar system for both electrification and the water supply system at the same time?
Oh, yes, definitely. I mean, that is, I brought the issue of solar here is because related to the discussion on what solar, on water supply and the water challenge. But of course, that is this, the access to electricity could transform a rural area because it generates power, electricity, lights, and other applications. So this is, about 90 years ago in the U.S., there is the Rural Electrification Authority that during the Franklin Roosevelt's time, and that really changed rural America. That it really transformed the rural United States because people have access to electricity. They can listen to radios at that time and transform their life. So this could be a transformational technology that having access to electricity. So not only just getting clean water, but also to for all other applications that having electricity could bring. So I agree with that, including even having telephone has a huge transformational technology.
I have a follow-up question here. Can I go ahead?
Yeah.
Yes, Tasamma, go ahead.
Yeah, my name is Tasu Makuria. I am invited guest by Dr. Ababa Getahun from Baltimore City Community College. The point I want to raise here, by the way, Dr. Endalkachew brought a lot of important information, and thank you for the lecture. And saying that, I want to ask a question that we know for sure that solar energy is cost-effective, convenient, and easy to use. And maybe it's not complicated for our farmers to train how to operate their solar panel and energy source in their garden. But we know for sure that getting the panels or grids is expensive. It costs a lot of money. And my question is, it's not probably for Dr. Endalkachew, but any other participant can answer my question. How is the plan to build the panels or the grids in African universities? That means so that the panels and grids will be distributed or sold to the farmers with cheaper and affordable price. So how is the plan to build the grids using the raw materials, and what are like the necessary tools and raw materials to build those grids and panels, and how can we build them? So what is the distribution if there is already one? And how is, for example, is Addis Ababa University is building or making those grids or canals? That's my question. Thank you.
Dr. Endalkachew, do you have a response? Otherwise, I can also chip in there.
Yeah, please go ahead.
I think the point that you raised is important. One of the main reasons for the not using solar system, solar panels in various areas, not only in desalination or in photocatalysis, is the cost of the material. The solar panel, the modules are mainly the ones which are in the market are silicon-based, cadmium sulfide, copper indium selenide based. These are down expensive. And although the price is going down, and that's why we find them here and there these days. And a lot of research is being carried in this area. If we see the whole Africa, there are only few industries that assemble panels. Production of the solar cell at the African standard is not also possible. What is usually done is the solar cell, the silicon production is very expensive. Although the raw material, the starting material is cheap, purification at high temperature is not that easy. And usually the solar cells are manufactured either in China or in other countries and then shipped to assemble them. And we don't have any module industry or factory, for example, in Ethiopia. There was one that was started by Metec, which is located around Sandafa. And it's not functional, and we don't have any. And the solar panels usually come from other countries, and that is one of the points that have to be worked out. And there are a number of research that are being done. For example, the research that's done in Addis Ababa University, one of the research is to make use of not such expensive materials, but use organic materials. A research which I do, for example, a research where we use conducting polymers, nanomaterials, dye-sensitized solar cells, and so on. The problem there is the efficiency is much better than it was some 20 years ago, which was below 1%, but now it's around 12%, which is at the verge of commercialization. But the problem is, the stability of these materials. For a solar panel to be used in the market, it should be stable for a minimum of 25 years. And these materials are not stable, even if the efficiency is improved. Even if that is the case, these materials are being used for, short period lifespan application. So the main problem, as I said, is cost. Yes, it is important. It is environmentally free, geopolitically it's important, and the sun is easily accessible. But as I said, cost is one bottleneck, and it is becoming better than before. But complete utilization of such system is not possible, and we don't have such factories in Ethiopia in particular. Assembly units in Kenya, in South Africa, in Egypt, in Morocco, there are module assembly factories like the one which I mentioned earlier, the Metec case, but we don't have any. That's one of the main reasons. Dr. Endalkachew, if you want to add, you can add on that too.
Yeah, I mean, this is a really an important question. I think we need to have at least an example, a demonstration of this, how it works. And as you said, the capacity for at least assembling at different scales and showing how it works for a small grid needs to be built because it's an important resource that could have a huge impact for the rural communities. But the panels, even in the US, most of it comes from made in China. There are very few countries. There is part that was also manufactured in the US, but in Germany. But the components of this come from other countries. But the capacity for assembling and putting a system and training operators needs to be built as an, and to build as an organizational capacity. So as Ababe mentioned that the higher education institutions or technical institutions have a big role to play in making this happen.
I see 3 more questions in the chat box. I don't know if you see them. One reads, what does interbasin water transfer mean? And what are the major challenges and benefits in an interbasin water transfer from Awash Basin to Rift Valley? And your recommendation. I don't know if it is clear.
I see that. I think that's a bit far from my area of expertise, but I see that water management issues, including that the ecosystem restoration of interbasin water restoration is important. So it just shows the scale of the problem, and that how water to provide a safe and sustainable drinking water system, we need to protect the ecosystem. So I'm not sure if I answered the question, but I think that's how I see it, because I'm a chemical engineer by training, and I mainly look at technology for water treatment technologies.
Is there anyone from the participants who would like to respond on this particular issue? It looks that the question is out of the topic that were presented here. So if there is anyone who wants to react on that. Okay, if not, let's go to the other question. How is the operation and maintenance cost, and how long it serves on average once installed?
So I think that is, this Professor Takatal just mentioned about in bit detail about the different solar panel designs and technologies, the old technology of silicon-based, and then there are others that came in the past year, the cadmium-based, and then there are newer technologies. Although the cost is decreasing, it has gone down, but then the cost of just the cell, but you have to look at the entire cost of from manufacturing to installation and bringing to the location. So it's the average cost here in the U.S. Right now. It's is about for a household, for example, is about $15,000. So it's for a small village, for let's say, how much would that cost in rural African? I don't know, but I think the initial cost, after the initial cost and the cost of the batteries for storage, usually they last at least 25 years, and that is the expected lifetime of this, of the current solar technologies. Now, I worked a little bit currently on disposal of the solar panels. There are a lot of panels that come even with shorter lifetime than 25 years. But the average life cost is 25 to 30 years.
In the chat box, there is, I think, one question left, which says, if I summarize it, solar energy is used for various purposes, for water pumping and energy conversion and so on. But the technologies that you mentioned, are they accessible to local community? Are these materials commercially available to be accessed by the community? I think, if I'm not mistaken, this is what it says. Are these technology available?
So I think that's, I'm talking here more in general that having energy, having solar energy and solar driven systems could be very critical in increasing water accessibility. Now, once you have the electricity, the power to drive this, let's say, electric ground pumps, and this has been tested in many parts in India and in Western, in parts of Asian countries, is that solar pumps are becoming very common. And so, yes, so it's, I think that requires, the priorities by local authorities to make this accessible to in these areas where they're off-grid areas where there is no electric power. So I think maybe someone in the audience can give you a better answer, but let's see.
I think if I understand the question, the use of solar for detoxification and the desalination, are these technologies accessible for local communities, for individuals, or for smaller communities, or it is a technology that have to be, used by the government or any NGOs and so on? That's the question.
Oh, okay. So that's okay. So that's a bit different. Sorry for missing it there. Now, water treatment, treating contaminated waters, probably is not for a community, but that is for maybe companies who are discharging polluted water, so they can use some of these solar-driven technologies for treating their effluent streams. So it's and some of the examples I gave are at an early stage of their development. They are not yet commercially available. But I think I just want to show that what are the capabilities that are not only just what's available, but once you come to start looking at the potential for using solar, there is in that space there are a lot of new innovative technologies that could be used using solar-driven power. So it's whether it's treating contaminated water or desalination, in addition to just electric generation. So a lot of these technologies are under development, but I think there are many that are available for like sodas. So it has some side effects, but some people have pointed out some, but that is being tested.
Okay. Are there any questions, comments, suggestions from the audience? I don't see any. I think we can conclude now. Thank you very much, Dr. Endalkachew, from my side. It was an informative presentation and interactive discussions. And I hope the participant also gained a number of ideas and points. And this is an important area because solar energy, as I said, exists in plenty, in larger amount, which could be used for various purposes. And this is also something that have to be extended, the research, something that have to be extended also here. I know that there are few PhD students who are working in relation to this at this institute. I hope this presentation will be plus for them. And from my side, once more, I would like to thank the participants and Dr. Endalkachew for this nice presentation. And I don't know if Faleka is there. I will hand over to Dr. Faleka to close the seminar.
Thank you very much for an excellent presentation, and thank you, our moderator, Professor Takattal. So we had more than 70 participants from many parts of the world. We'll have, I think, more specific discussions. We'll create more forum, platform for such discussion regarding the use of solar energy for water supply, wastewater treatment, food security, and so on. As Professor Takattal said, we have some ongoing research in addition to what Dr. Endalkachew mentioned, the biodesalination. In addition to that, we have solar systems, systems for fluoride and arsenic removal. We are working on, again, removal of dyes from textile effluents, and so on. So there are a number of applications. I think there is an ample room for collaboration in this regard, and we are very much, we look forward for collaborations to expand, to establish solar-based systems in Ethiopia and in other African countries. So thank you very much. I would like also to thank all the participants for their active participation, and thank you very much all. And we will see you in our next month's seminar that is more related to wastewater reuse. Thank you very much.
Thank you. Bye-bye.
Thank you very much. Bye-bye.
Bye.